Module. We are completely done with module 1. We're moving into module 2. This one is going to focus on ratios. Today we're going to look at additive and multiplicative relationships between quantities. We're going to get to the introduction of the concept of a ratio and look at writing ratios in different forms. The rest of it will be next time's class. Homework tonight, just 2 Matthew workspaces. It's the differentiating additive and multiplicative relationships and using ratio relationships. So by the time you're done with this, you should have had 31 total completed workspaces. Everybody good on those? Okay, open up in your modules to page 167 in your math book. Math book's page 167. Again, you can see our learning goals, what we're doing today. We're going to start with 2 quick review questions. All you're going to do is read the questions, make sure you're putting them in full sentence answers, since these are word problems. So it should only take you guys about 2 minutes. These aren't hard ones. You may work together as a table if you want to. Go ahead and work. Okay, our first one should have been pretty easy. Laquan put $15 in savings this week. That was $3 more than the amount he put in last week. How much did he put in last week? So there's our question. So who had the answer on that one, Maverick? How did you get that? But it said more than. Are you sticking with your answer? Brandon? It's more than last week. You should have stuck with your answer. You were right. Okay? But that's what I wanted to point out to you. Just because it says more than doesn't mean it's automatically going to be adding, right? You had to look at the relationship. It was more than last week, but they gave me this week. So if they gave me this week and I'm looking back, that means I would need to subtract. Does that make sense to everybody? So last week, he put in $12. Again, guys, I'm going to ask you whether you're right or wrong. Just because I ask you if you're sure of your answer, don't change it. Make sure you're ready to defend it. Yes, Maverick? I gave you the last one. Go ahead, Liam. Yeah. That's interesting. I would have called it Mitchell.
So I thought it was a girl. Joanne and Michelle.
Michelle is normally Michelle.
I'm not good at spelling either, so.
But his math is good, right? So this time, 3 times as much. They told me Mitchell was 5. 3 times 5. Joanne bought 15 books.
So it's like this citing the text.
Yes, it's very much citing the text. But it's citing the text and making sure understanding what's going on and what the relationship is. So really, today's initial part is all about, am I multiplying, am I adding, and understanding the difference. And when I say multiplying, I mean multiplying or dividing. When I say adding, I'm saying adding or subtracting, because those operations go together, right? Like 2 peas in a pod. Okay, so we're not going to worry about the bottom on this one. Let's go ahead and turn the page. Here, we've got a basketball game going on. Crusaders and Blue Jays just finished the first half. They've given us a thing of a screenshot of the scoreboard. All I want you to do, predict the final score, but explain how you got there. So I'll let you work as a table on this one. So you can talk to each other, figure out what you think the final score will be, or you can do it by yourself. But in either case, make sure you include your reasoning. So I'm going to give you guys like 5 minutes because you have to reason this as well. Okay, who can tell me what final score you predicted? Sophia?
Me and Raina, we didn't really know what was going on, so we just estimated what likely and unlikely.
Okay.
And we thought the Crusaders would win 60.
And what would the Blue Jays have? So you think it would be 60-40?
Yeah.
How many can support that? Feel like that was a pretty good thought?
Yeah.
Okay, anybody have something different? Tita? 50-40? Okay. When you're losing, you get motivated, so you're going to play harder, right? So they'll probably play better defense. They're not going to let them score as many points. Still going to end up losing, right? They still lost, didn't they? But not nearly as much as what Sophia was saying they were going to lose by. So does that make sense to everybody? Can you understand where that score would come from?
Yeah.
Would you be okay with that as a final score?
Yeah.
Okay? What if I said the final score was going to be 31-21? That doesn't make any sense at all, does it? Okay? So when we're making predictions based on numbers, there's several different ways we can do it. Some of them make sense and would be applicable. Some of them don't make sense. Okay? You need to have some reasoning behind what you're doing. And that's what we're going to talk about today. Some of that reasoning. So, Robina and Aaron are looking at this exact same game. They came up with two different thoughts. Robina says, I think it's going to be 60-40, just like most of you did. So basically, it's going to be double the score at halftime. I don't know if Tito looked ahead, but he was using Aaron's reasoning. Thinks the Crusaders are going to play hard enough to stay 10 points ahead, but the Blue Jays are going to step their game up. They're not going to get 30 on them again. They're going to keep it a lot more even. So they said the score will be 50-40. You can see that they both have a thumbs up, right? So both of those reasonings are okay. So what reasoning do you think that each of them used? I'll give you a hint. If we go back to our introduction, we have additive and multiplicative reasoning. So if I look at those scores, the final score of 60-40 from 30-20, which kind of reasoning do you think that is? Additive or multiplicative?
Additive.
Why additive?
For Aaron?
No, for, this is the 60-40 score, not Aaron's score. Why multiplicative?
Because you're multiplying them both by 2.
So I just multiplied them both by 2. So we're saying that Robina was using multiplicative reasoning. She just multiplied both by 2. Okay? Whereas Aaron, and this is kind of a process of elimination, was using additive reasoning. She just added and actually the key is, how far apart are those two?
10.
How far apart are those two?
10.
10. So the difference stayed the same. In other words, you were adding the same amount to both. So please make sure you write that down in your book, since I didn't really give you guys time to talk about that one. So Robina was using multiplicative reasoning. She just took both of their initial scores and multiplied them by 2. Aaron was using additive. The difference between the two is always going to be the same. So that means we just added 20 to both of their scores from their first half score. Where's your math book, Austin? So you're literally just going to sit here the whole class and not do anything. Probably a good idea. Okay, so based on the predictions, which team scored more points in the second half?
Based on both her things, it's the Crusaders that won in both.
They won in both, but that wasn't the question. Which team scored more points in the second half? So for Robina's, did a team score more points? The Crusaders scored more, right? Because she said They scored 10 more the first time. They're also going to score 10 more the second time. So the Crusaders scored more under Robina's reasoning. What about for Aaron's reasoning? No, they still won, but which one scored more in the second half?
Crusaders by 10 points. Because the Blue Jays have 4.
No. So in 30 to 50, that was how much? No, 30 to 50.
Oh, 20.
20. 20 to 40, that was.
Oh, they have both the same numbers, so it's
They scored the same. And this is really one of the biggest differences between additive reasoning and multiplicative reasoning. Because in multiplicative, that difference is just going to keep multiplying itself out. You're going to see it grow larger and larger. For additive reasoning, the difference between the numbers is always going to be the same. Yes? Go quickly. We don't have that much time left. Okay, let's go ahead and flip to 172. We need our highlighters. We got a couple of definitions here. So we've already started talking about it, but we can use additive reasoning, which focuses on the use of addition and subtraction for comparisons. Or you can do multiplicative reasoning, which focuses on the use of multiplication and division. So even though we're only using half the term, in other words, additive includes addition and subtraction. Multiplicative includes multiplication and division. Those are the related operations. So we already answered number 2 on the last page, so I'm not going to stress on that one. But now we've got another scenario. Vicki and her nephew Benjamin were sitting and talking. Vicki says, "Today I'm 40 years old, you're 10, I'm 4 times as old as you are." Her nephew Benjamin is like, "Wow, that's cool, you're old." Vicki says, "But in 5 years, you'll be 15, I'll only be 3 times as old as you." Makes sense, right? Mm-hmm. So Benjamin's like, "Wow, I'm catching up to you. I went from 4 times to 3 times, right?" Yeah. Now Vicki goes, "And after 15 years, I'll be 60 and you'll be 30. Then I'll only be twice as old as you." So Benjamin's like, "Wow, in enough time, I'm going to be older than you, Aunt Vicki."
No.
Is Vicki correct about how their ages change?
Yes.
She is?
Well, yes. She's correct how it'll be 60 and 30.
And that's 2 times? Is Benjamin correct in thinking he will eventually be older than his aunt?
No. She dies. No. She stays at 1 year.
Oh, wait.
When she dies, he can be older.
Yes.
Really?
Yes. No. Because if she dies at 60, when he's 60, he'll be 60.
Okay, so this is an interesting concept, so let's bring real life into this. My dad died in 2003.
No, how old is he?
He was 63 at the time.
You can bring it back into this.
So, every July 20th, I still think of my dad, and I think of his birthday. Do I still think of him at 63 when he died?
No.
I don't, do I? I think of him in terms of how old would my dad be today if he was still with me, right? It is sad. But y'all are saying just because Vicki died, she no longer exists. Her age doesn't advance anymore.
Her spirit exists, but it doesn't age.
Her heart is not beating anymore.
But is Benjamin ever going to actually catch her?
No. No.
Even if she's dead, you still count it from her birthday. You would add whatever age she is from when she died. You wouldn't just say, "Oh, she died, that's all she'll ever be," right? So let's think about this again. Is Benjamin correct, thinking he'll eventually be older than his aunt? Will he ever be older than her?
No. Like,
Never ever.
they're always 30 years apart.
Okay? Which is what we're going to get to in just a moment. So, is Vicki correct? Vicki is correct. What type of reasoning is she using?
Both.
Multiplicative.
Yeah.
Okay? So she is using multiplicative reasoning. Is Benjamin correct?
No.
Benjamin is just flat wrong. So even if his aunt dies, her age will still continue because it's based on when she was born, not what if she's still on the earth or not.
It's all you.
Now her age still doesn't, it still changes based on when she was born. Okay? But I do agree what happens after they die is totally up to religious perspective. So we built a table that shows this entire conversation. We have B that represents Vicky's age and B represents Benjamin's age. So we've given the different numeric values at each stage of their conversation. What I want you guys to do is go through, you're going to fill in this last table, last row of the table with whether it is multiplicative or additive reasoning. And then at any point, which relationship does not change. So once you've filled out the table, do a comparison of the different numbers, see which values don't change. So I'll give you guys about 4 minutes to work on that one. Our first one, guys, the first one where it says, I'm 40, you're 10, that's an additive. Okay? Then when you change it, it says, I'm 4 times as old as you, that is multiplicative. Then in 5, I'll be 45, you'll be 15, that's again additive, she's adding the 5 to each. Then I will only be 3 times, that's multiplicative. Okay? Then again, after 15, so now she's adding the 15 to each of them again. So additive. And then I'll be twice as old, so we're looking at multiplicative again. Does that help it make sense as to what those relationships are? Additive versus multiplicative. Now, as you look through the list on the equations, which one never changed? Additive. It was the exact same equation every time. So for part B, which relationship does not change? Additive never changed. Because that was just looking at the difference between the two ages. Which even after Vicky dies, as we've noted, that relationship will always be there. His aunt will have always been that much older. Okay, going to page 174. Here's where we're getting into the ratios piece. Ratio is just a comparing of quantities. Ratios are awesome. They're very easy. Okay, the school colors at Riverview are a shade of green and white. Our teacher knows to get the correct color of green, it takes 3 parts of blue to every 2 parts of yellow. So there's different ways we can think about this relationship. A lot of times, having a picture of it can help you. So if I looked at a picture, I would have 3 gallons of blue paint for every 2 gallons of yellow. Does that make sense?
Yes.
And if we mix those, we get the appropriate shade of green for their school colors. So for the model, if I looked at it and I wanted to write a ratio comparing blue parts to yellow parts, how would I write that ratio? How many blues are there? Brandon? How many yellows?
2.
And when we write a ratio, all I do is I put a colon between them. So I would say that is 3 to 2. In other words, I need 3 gallons of blue to every 2 gallons of yellow. Does that make sense? What if I looked at it from yellow to blue? How would I write that?
You just swap it.
I would just swap it.
Because orders matter to ratio.
Excellent. Thank you very much. That's that next key point. Order matters in ratios. Whatever is listed first in English, I list first mathematically. Whatever is listed second in English, I list second mathematically. But we can also look at it as a total. So if I looked at it for blue parts to total parts, how many blue parts are there?
3 to 5.
3. And how many total? Does everybody see that? Actually, let me rephrase that. Does anybody not see those two numbers? Hannah, you're not writing anything? What if I did it as yellow parts to total parts? 2 to 5. Because now I have 2 yellows to 5 total. So here's where we get back to our definition. So pull out your highlighters. So our basic definition, a ratio is a comparison of two quantities by division. Okay? So our first column are what we call part-to-part ratios, because we're comparing the individual quantities that make up the ratio. You're not writing or highlighting anything, huh, William? The comparisons in the second column are what we call part-to-whole ratios, because I'm comparing one of the parts to the total number of parts. So really, the types of ratios make sense if you look at the names, right? Part to part, I'm looking at the pieces that I'm comparing. Part to whole, I'm looking at one of the pieces compared to everything, part to whole. So understanding these definitions will help make it easier for you to be able to write all of the different pieces. The bell rang earlier today, so I'm thinking my clock's off. Just a reminder, 2 Matthew workspaces tonight. If I look at this, and I changed it, and I said it's 2 parts blue to 5 parts yellow, could I now write a different part-to-part ratio?
Yeah.
Yeah, what would it be?
So 2
to 5. So 2 to 5, but then normally whenever we write a ratio, we need to include what it is we're comparing. Because if I just have 2 random numbers out there, does it actually mean anything? No. But now that I've written 2 to 5, blue to yellow, can you tell exactly what it is?
Yeah.
Yes. I could use another part to part and just reverse the numbers, and I would reverse how I'm writing them. Blue, yellow to blue. That was easy. Okay? Or I could do part to wholes, right? I could say 2 to 7, and that would be blue to whole. I could say 5 to 7, that would be yellow to whole. Yes?
In the fifth math back in Arizona, this was probably my easiest subject. Probably the easiest subject out of it all.
Good. This is a funny one. This is one you either really get and it's super easy, or you just really struggle and it's hard until you get it. Okay, let's go to our last page. So, I think the bell's about to ring. Raise your hand if you wear glasses. So I see 1, 2, 3, 4, 5, 6. So we have 6 of us that wear glasses. The rest of you don't. So we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 in the room. So that would mean 14 that don't wear glasses. Does that make sense? So this would be glasses to no glasses. It is really important, guys, that you include your description of what the ratios is. Johanna, you just decided not to do any of it today, huh? What about the number of students who wear glasses to the total number of students?
It would be 6.
6 to 20.
I think you kind of wrong. There's actually 19 people in here.
But I counted myself.
Yeah, I counted you as well.
4, 8, 12, 16, 20. Okay, and this would be glasses to total. I included myself. Okay, number of students not wearing glasses to the number of students wearing glasses. What ratio would that be? I think, Melinda. The ratio of students not wearing glasses to the number of students wearing glasses. The number of, part C, the number of students not wearing glasses to the number of students wearing glasses. So part to part, right? So 14 to 6, and that would be no glasses to glasses. What about the number of students? Are you trying to leave or are you coming back? You shouldn't be leaving with 3 minutes left in class. Okay, the number of students who are not wearing glasses to the total number of students. Right, but you shouldn't have left within the last 10 minutes of class. Number of students not wearing glasses is 14 to the total number of students, which is 20. And that would be no glasses to total. Are you guys seeing how these are built? Understanding the relationships?
Yes.
Okay? Ezekiel, I hope you finished your quiz because I'm going to have to grade it. Okay, I want you guys, just looking around the room, see if you can make up some ratios. Include your descriptions. I can give you a hint. You can look at stuff like the number of lights that are on to lights that are off. The number of red shirts to the total number of shirts. So
How many people have
make some comparisons. Make sure you write down the quantities
How many
in a ratio with their descriptions.